Now we'll see here it is. Already I told what is network and host versions. You may not know. Some of you know already. Some of don't know this one maybe. If your background is mechanical and digital electronics is less, but not required digital electronics here. If you know the 10th class max, we have one truth table is there. Okay. Before going to truth table, then I will say this is the range. I will put everything into one place only. So in an class A IP address, the first portion is network portion and remaining is host portions. Class B, first and second are a network portions and last two is host portions. In class C, first three are a network portion and last one is host portion. Okay. So if you write class A IP address, it means the first portion is network portion, all remaining are host portions only. Okay. Just for an example, I took a 11 dot 0 dot 10 dot 100, 11 dot 0 dot sorry 20 dot 30 dot 44. Both are in a same network only. How? The first portion is the same, so it means it's a class A IP address. First portion is same, it means these two PCs can able to communicate. This is one PC IP address, this is another PC IP address. So these two PCs can able to communicate each other.
Because of same network, na sir?
Because of both are in same network. Network ID is same. Okay, network portion must be same. Host portion is different, no problem. Here if you see the network portion is different. Network portion is different. It means it won't communicate it to these two things. Okay, it won't communicate it to these two things. Even though if in case if I change like this, even though it won't communicate. Even host portion is same, network portion is different, it won't communicate. If you give next number and accidentally you put a 2, it won't communicate. So we have to verify. You have to verify the network portion first, which class it is, and verify the network portion. Yes, because of both are in same network. How we can say same network? Network portion must be same here. Okay. For example, 150 dot 13 dot 14 dot 22 something. 150 dot 13 dot 22 dot 44. Both can communicate each other. How can we tell? The first portion and second portion is both side is the same. Here is a 150, here is a 150, 13, 13. Both side network portion is same. So in a class B, first two portions are a network portion. If both are same network portion, it means they can communicate each other. For example, if I take 151, 13, 22, 45, this is won't communicate to these two PCs. Why? Because of different network portion. This is 150, this is 151. 150, 14, 22, 46. This is also won't communicate to this network. Why? Because of 150, 150, same. But here it is 13 and 14. So you have to verify all the network portions. You have to verify all the network portions. Something I taken. So 200, 20, 20, okay, 11. So these will communicate each other. See, 200, 20, 20, 200, 20, 20. So it is in a same network only. Host portion is last portion only. If you take 201, 20, 20, 12, it won't communicate because it's in a different network. Because network portion, one of the network portion is first one is a 200, this is 21, 201. Okay, by mistake I put a 21 instead of 20. So what happened? This is also won't communicated to these networks. Why? Because of one of the network portion is different. You have to check all the network portions. You have to check all the network portions. All network portions are same, then only they will communicate each other. For example, you have a five pieces. These two pieces are communicate each other, but these pieces are not communicating to anyone. Why? Because of there are in a different networks. You must check the all the network portions. If all network portions are same, then only they will communicate each other. So that is this one. Okay. So that is why we have to see network portion and host portion thing. So based on this, they're giving a default subnet mask also. How our system understand which network you are belongs to it, what is your network portion and what is your host portion. So to define that one, they are giving a subnet mask. This is a subnet mask based on your network and host portions. Okay, like that. So 255.0.0.0 for class A and 255.255.0.0 for class B, 255.255.255.0 for class C. Okay, and here we have to understand few things because already I told why it is divided. So in each network, each class, we got some kind of IP addresses. For example, if you go to the class C, what is the host portion? Host portion means number of PCs we can able to connect. That is called host. Okay, host portion means number of PCs or devices we can connect. See here it is. This is a constant for throughout the network. So you will see. So 200.20.20 is a constant throughout the network. This is a starting IP address. I'll take here 1, 2, 3 like that. We can able to put it. Uh, then go to 254 and last one is 255. So this is a one set of a class C IP address starting with a 0 ending with this one. If you go to the next level, now it is go to like this. Here it is a different network. This is a one network and this is a different network. So if you see the network ID is changed automatically. Automatically network ID is changed. So this is a different network. This is one set of network. The first one we call it as a network ID. Network IDs we can't assign to anyone. Network IDs we can't assign to PCs. It won't agree. Next, last one we call it as a broadcast ID. Last one we call it as a broadcast ID. Within this network, certain protocol want to broadcast to everyone within the network only. Want to broadcast to everyone within that network only, within that logical network only. We use destination IP address as a this one. So 200.20.20.255 like that. Just for an example. The first IP address is called a valid IP address. First valid IP address. or a first host address, also we can call as valid host address. I put both the things here so to avoid confusion. So why we two statements, one statement only. Valid IP address or a host IP address or a valid host IP address. Anything is same. This is IP address and last one also IP address, but the first one is a network ID, last one is a broadcast ID. That's why this is called a valid host address. Out of that one, this is the first one. All are valid IP addresses only. From here to here, all are valid IP only. This is the first one and this is the last one. Last valid host address or host IP address, anything you can say. So this is entirely one network. Of course, these are valid host addresses, and one is network ID, another one is a broadcast ID. So these we don't use it to configure to PCs. So if you open a PC, static 200.20 dot, I think you can't see 20.0. So it is showing invalid IP for this subnet mask entered. Okay, 200.20.20.255 invalid IP address. 200.20.20. Um, 200. It is not throwing error. 1. It is not throwing error. 2. It's not throwing error. 254. Not throwing error. 255. Throwing error. Okay. So that is what it is. Okay. Okay. So this is that's why these two IP addresses we can't assign to host, but these IP addresses we can able to assign to host. Got the point? Okay. Like the only last portion only change. First three portions network constant. So here it is how much of host portion is, it is nothing but last portion, right? 8-bit number only there because it's a 8-bit. Okay, it's a 8-bit. So 2 to the power of 8 minus 2. You have to do minus 2. Why minus 2? Network ID and broadcast ID we are not assigning. So actual number of hosts per network, actual number of hosts per network is 2 to the power of 8, means number of host bits minus 2. You have to do minus 2 because 2 IP addresses in a total range we are not using. Okay, so 256 minus 2 is 254 because it's a smaller number I've written first. Okay, next I have a two host portions here. In a class B I have a two host portions. Okay, so 2 means 8 bit plus 8 bit. 2 means 8 bit plus 8 bit. So total is 16 bit host portion. 2 to the power of 16 minus 2. So how much value? So we have to go to calc C. Open a calculator. 2 to the power 16. 65,536 minus 2. 65,534. 65,534 IP addresses we are getting in a single class B network. Here it is. Three host portions are there. Here We have a three host portions. How many bits? 24 bits. 2 to the power of 24 minus 2. For any IP address, minus 2 is compulsory. Any range. So here clear. So 2 to the power 24 and minus 2. So I'm doing minus 2 here only. It is 16 million 16,777,214. So as per American system, but here we can say like 1 crore 1 crore 67,000 1 crore 67 lakhs 77,214 214. So these are the number of hosts per network. For example, if you see this is a one network, right? If you go through the class B network, for example, class B network, I'm putting some number like this. This is the network ID 172.16.0.1 is a first valid host IP address. Valid host means we can assign. Now 172.16.0.2. So here keep on going. It will reach the last one. I first 1 2, last 1 2 only I will write. This is the last valid host IP address. This is a broadcast ID. So this is the range. Earlier it is only one portion. Now it is two portions are effective. Two portions are effective. But network portion is constant from there to here. If you go to next IP, it's become 17.0.0. Okay. So if you see 17 came up here, it means it's a different network. This is a total one single network, and this is a different network. We can go through class A also. For example, 10.0.0.0 is a network ID. 10.0.0.1 is a first valid host. 10.0.0.2 this is a second host. So we have to keep on going this one. 10.255.255.254. This is a last valid means up to here we can able to assign to client. 10.255 255 255 is a broadcast ID. Okay, so this is one network. If you want to go next one, then it is become different network ID. So this is one single network, because for entire all these IP addresses, like what are the IP you taken, so you can keep on going like that, write down all the IP addresses. So you will get 10 is a common in a first place. When first network portion is changed, it means you are in a different network. So these are all can get connected, communicated each other. How many are there? So many are there. Okay, like this. In a class A, it means that many 16 million IP addresses range. This is more than 16 million IP addresses, 16 million 777,214, 216 IP addresses minus 214. This is 214. With this one 216. Here 65,000. This range is up to here is a 65,536 minus 2 means broadcast ID and network ID. It means this range alone is 65,534, and this total range is 256 IP address minus 2 of broadcast ID and network ID. So the valid range is a 254 only. So this is the ranges, and why we need these ranges. The one example I will tell first. If in case in your organization you have a 100 PCs are there. Now you have a 100 PCs. Which class is better class? Class A, class B, class C. Which class is better? Anyone?
Depends upon the number of system we
Yeah.
require.
Yes, 100 PCs are there. Which class is better? Your boss is
C,
asked you. I have 100
C,
PCs.
C,
Hmm?
Class C.
Class C. Very good.
C.
So class C. Why? Because class C 254 only. Class C total is 254 only. If you take class B 65,000, what you will do with the remaining IP addresses? So suitable one is class C. Now your boss added 100 more pieces. Which is the better one? Class C only, because 254, right? So you have 200 only. So 254 best utilization. Then your boss added something around 100 pieces again. What to do? We change it to
Class
class
B.
B. We change it to class B. Now class C no longer class B, because it is crossed more than 254, now 300. Compulsory class B only 65,500. And he purchased a new organization. That organization having a 70,000 pieces are there, more than 65,000. Just for example, 75,000, 70,000, more than 70,000, 65,000 pieces are there. Then we have to go to class A only. No choices, right? For 100 pieces or less than 250 pieces, we choose class C. If more pieces are increased, more than 250 or 254 pieces, we will go to class B. Depends upon the network number of hosts, we'll go to classes. Very good, guys. Okay, so that's why I told this much of stories and that. Okay, we should understand number of hosts for a network. What network having number of hosts? Okay, network version and host version. The question is here. Next question: how system will understand which one is network version and which one is host version? This is very important point. So that will be an AND gate. It will do ending operation. That is called ending operation. This is AND gate. What is AND gate? A, B as an input, Y is a output. So A dot B is a function. Got it? A is an input, B is a input, Y is an output. Y function is A dot B. So 0, 0. Your both inputs are 0, 0. Output is 0. If 0 is a input and 1 is another input, output is 0. 0, 1, 0 as a input, output is 0. 1, 1, output is 1. So this is a logical one we are getting here. If input is both inputs are high, output is high. If any of the input is low, output is low. This is called a truth table. This is called a truth table. No, no is equal to no, like that it is then a true, yes, yes, false, false, false. false, true, false, true, false, false, true, true, true. Do you remember anything 10th class or intermediate time? I don't know what your syllabus. I think you know, guys, this part. AND gate. But if you don't know, no problem. Just understand AND gate. AND gate, OR gate, NOR gate. So many are there. So I will give you one example. Understanding of there is a two numbers are there like this. We have a two numbers. This is one number. This is one number in binary. I want to do ANDing operation. So look at this first one. First one is 1, second one is 1. So what is output? Both are high. Output is high. Here is a 0 and here is a 1. So 0 1 means 1 is a low one, right? So we'll get a 0. Again 1 1. We get a 1 1. Okay, so we'll remove this one. Change it. I wantedly. Okay. Um, then I will put it here like this. So it is quite easy to understand. 1. Okay, it's okay. Okay. 1 0. Again you will get a 0. 0 0. You'll get a 0 only. So this is the value of ending result between these two things. This is the value. And also I will give you another one. 4 bit only for understanding. 0 1 0 0 0 0. For example, your second number is all are zeros. What is an output? 1 0 0 0 0 0 1 0 0 0 0 0. Output is 0 only. So you don't need to calculate actually. So if all are zeros in a one side, any of the side all are zeros, it means output is 0 only. I took another number. Okay, I took another number. I put all ones as the input. So 1 1 1 1 1 1 0 1 0 0 1 0 only. If all all are ones, you'll get a same only here. Like that, your ending operations will work. Now we'll see how to calculate network ID and how to make sure that systems are communicating each other. So this is the classes. These are the default. These are the default subnet masks for each class. Okay, so I'm removing these things. So these are the default subnet masks for a classes. Okay, class A 255.0.0.0, 255.255.0.0, 255.255.255.0. These are the default subnet masks. Okay, you have to read all these things. Last time they asked all the questions, all the questions like there's suddenly they're asking. Even I didn't expect they will ask a subnet mask and all. Okay, so how to calculate? For example, I'm taking IP address 102 dot 34 dot 33 dot 55. So anything. What is subnet mask? 255 dot 0 dot 0 dot 0. Why? Because it's a class A. Because it's a class A. What is 255? What is 255? That I will write here. What is 255? Nothing but 8 ones. Okay. What is 0? Means 8 zeros. Means all are zeros only. So to easy to calculate, I will tell very simple technique is 102. 102 means some binary number you have to convert 102 in binary, 55 in a binary, 255 in binary, and do the ANDing operation. If you convert no convert in it nothing but all are ones means it is a repetition of number. It means it's become 102 only. Zero means all are zeros. What are the binary number of 34? You will get a zero only. Same thing will happen to others. 33 and zeros means you will get a zero only. This is a network ID. Network ID of this IP address and with this subnet mask. This is the network ID. So network portion only, their remaining become zeros. If you take 102, 134, 245, okay, 31. If you take this one, same thing, do ending operation again. I'll give you a small size here. Okay, yeah. Now again, 102. So if you got a doubt, I will explain. 102. Convert into binary. Convert into binary. How to convert into binary? So first one is 0. Next one 64. 102 minus 64. 102 minus 64. 40. 42 minus 4. 38. So 1. So it's 38 minus 32. Yes, 64. 38 means 32. Now we will get 6. Okay, and this is 16. 8, 4, 2, 1. So this is the value. If you got a doubt, then you can able to check in a calculator also. Okay, 102 in binary. See like this: 110, 0110, like this. Calculate. What you will get it? 0110, because 01, 0, 11, 1, 11, 1, 01, 0, 01, again 0, sorry, 0, 11, 1, 111, 00. See, same only you are getting 102. Okay, same only you are getting. Same thing like if you go to 34. 34 is easy. 134 is easy. I will show you one example only. So 34. 34 is easy. That's why I took 32, 0, 0, 1, 0. This is 34. Where is the calculator? So don't close the calculator now. 34. So this is the binary number. 0010 and 0010 this side. So 10 0010. Okay. So if you put a zeros, what will happen? Because that's a binary number, right? Come here. 000 000. 100 1 0 0 0 0 0 0 0 0 0 100 0 0 0. So this is what is thing is it is nothing but 0 only. That's why I put it directly zeros. 102 0.0.0 like this. This is our network ID. So both systems having same network ID, we can say both are in a same network only. Which is look like a different IP addresses. See, it is 34. It is 134. Immediately we think maybe it is different network, but this is a network portion and this is a subnet mask. And if when you calculate network IDs, if both network IDs are same, they will communicate each other. Both the network IDs are same, it means they will communicate each other. Remember this one. Both network IDs are same means device communicate each other. So this is it. PC or a device or communicate each other. Okay, so this is about your subnet mask, and use of subnet mask is to separate or define what is your network ID. It will define what is your network ID. Okay, we have a network ID, subnet mask, and we know already which one is network portion and host portion also, right? We know which one is network portion, host portion, and why we need this subnet mask. Okay, we can fix it, right? But we don't do that one because we call this one as a default subnet mask. Default means by default, right? It means we can able to change it also. We can change it also. We can change the subnet mask. I'm taking the same example. I'm writing here. I'm taking same example. Now I change my subnet mask. What is network ID now? 102, 102, 34, and you will get a 255 here. It means it's a 34. 33 0 0 55 0 0. Now the network ID is changed. Here also I'm changing to 255. Okay. Now what happened? 102, 255, 102 because all are ones. 134, 255. I got a 134. 245 0 0, 31 0 0. Okay, so now I changed my network ID. I changed my network ID, and automatically, sorry, I changed my subnet mask. Automatically network ID is changed. Now these two pieces won't communicate each other. Both are in different networks. Earlier both can communicate each other. Now they can't communicate each other. Why? Their network ID is different. The network ID is different. How it is different? I change my subnet mask. If I change the subnet mask, the network ID is changed automatically. Network is different now, so they can't communicate each other. Okay, this technique we use it. This technique we use in subnetting. Technique we use in subnetting. What is a subnetting? Is divide a network into smaller parts. What is subnetting? What is subnetting? Divide a network into small network. divide a network into small networks, sub networks. So that we call it as a now sub network, subnet, okay? Subnets or a sub networks. You can call that one as a subnets or a sub networks. Okay? Divide a network into small network that we call it as a subnets or a subnetworks. Okay, so the concept is subnetting. Okay, how to divide it? By simple, how to do it? By changing subnet mask, then automatically it will the network will change. So we can see different way of doing it, like a VLSM, FLSM concepts. Okay, okay, we'll see that one. Okay, guys, do you got this point? IP address and subnet mask.
Yes, sir.
Okay, IP address, network portion, and subnet mask. This
Mhm.
also important. Okay, so like suddenly they ask, what is a class C network portion? Network host. Last portion is host portion. Class B subnet mask 255.255.0.0. So you have to practice daily. Okay.
Okay, sir.
Okay. So what's the time? Almost 6. Okay. Maybe we don't have a time. Okay. So that's enough. Subnet